Hello, class. I'm going to go over the correct number 9, the Cartesian rectangular coordinate system in your workbook for statistics. Let's see. All right, class. So at the top, I'm going to put correct number 9. And then I'm going to add the word Cartesian. Cartesian rectangular coordinate system. Okay. And so this is the rectangular Cartesian coordinate system, and it's named after the mathematician whose name is René Descartes. And he's the famous French philosopher and mathematician. And he's the person who receives credit for the idea of graphing and plotting points. And so the idea is you woke up one morning and saw like a fly, an insect on the ceiling, and thought, how can I identify where this bug is situated at? And then he came up with this idea of this coordinate system. Um, and he was also a tutor for Queen Christina of Sweden, um, back in like in the 1650s or so. So he tutored Queen Christina. Her last name was and this is of Sweden. She's of Sweden in 1650. Okay. And so back in the day, it was very cold, right, in Sweden. And so unfortunately, he wasn't used to the very, very cold weather, and back then they had castles and things like that. It was very cold. And she was very young. She's probably in her early 20s, a young queen. Um, and so he actually caught pneumonia because of the cold weather. He wasn't used to the climate. And so, unfortunately, he died while in Sweden. He contracted pneumonia and died. And so, but is known as a famous mathematician and philosopher, and does get credit for this idea of plotting points. Okay, so a little bit of history. Those of you who are history buffs, if maybe are history majors and you like history, it's quite interesting. And she did. When he tutored her, because he was also a French philosopher, she did do quite a bit of writings. Her writings are very interesting, and also tutored her um, with the philosophy as well. Okay. Okay. So notice on this Cartesian plane that the region is broken up into 4 quadrants, and it goes counterclockwise against the movement of the clock. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we usually tend to use these Roman numerals to represent the quadrants. So we say that points, they either reside within a box, within a quadrant, or they may actually exist on an axis, either the x-axis, this is the x-axis, this is the y-axis, okay? And then we have the origin, the belly button, if you will, right, the centerpiece, right, of this Cartesian coordinate plane, the origin, which is denoted as 0, 0, okay, for the origin. Okay. And so it says here that points graph in a rectangular coordinate system are defined by two numbers as an ordered pair, some x and some y. Okay. So that's the ordered pair. So the movement along the x axis followed by the movement along the y-axis. Okay, the first number called the x-coordinate or the first coordinate is the horizontal position from the origin. The second number called the y-coordinate or the second coordinate is the vertical position from the origin. Okay, um, and so let's see. Um, in the movement to plot a point, so we have this x and then this y. So we always begin at the origin at 0, 0, and then we do our movement. So for x, either you stay at 0 or you find yourself moving to the right if x is positive, or you find yourself moving to the left if your x is negative. And if x happens to be 0, then we say you stay in that position. Okay. And then you hold your pencil. You don't put a point just yet because you have to honor your y coordinate. And then on your y coordinate, it could also possibly be 0, which would mean you would stay. Or if your y is positive, you would find yourself moving upwards. Or if your y is negative, you would find yourself moving downwards. And then you would plot your point, plot it, and then you would label your point. Okay. And so the idea of graphing is important, um, for reading maps. You need to read coordinates on a map. That's important. Um, And sometimes when students are learning, they get confused as to the order in which to move. So you have to remember it is alphabetical order. You move according to your X's first. So I often think of it as to help you remember that. Imagine you're the first person you're in a car, right, at a um, on the highway at a stoplight. Let's say you're at a stoplight. You're the first in line there at a stoplight. And when that light turns green, you oftentimes have to wait a few seconds, right? Because somebody might be trying to cross the intersection and run a red light, right? Try to go through the yellow light, and it could be dangerous. So oftentimes, if you're the first person at a red stoplight when it turns green, you have to pause and you have to look to the right, you have to look to the left, make sure nobody's coming, and then you either proceed forward or you just hold off or you back up a little bit, right? And so that's kind of the idea here when you're graphing and plotting points. The order is you have to either move positive direction, move right, or move left, or sometimes you have to wait and you stop at 0. And if everything is all systems go, then you can move forward, or maybe you might have to back up, okay, a little bit. All right, so that'll help you with your movements, okay? So on the bottom, plotting points in a rectangular coordinate system. So they want you to plot the point -5, -3. So you can see their advice here is they're telling us that you start here. You start at the origin at 0, 0. And then the -5, you can see that they're instructing you to move left 5 times. So 1, 2, 3, 4, 5. And then you can see that they hold the pin, so they don't put a point just yet. They hold it and then they move down. They move down 3, 1, 2, 3, -3. And then they plot their point right there. -5, -3, and then they label that. Okay. So the point -5, -3, where is it located? Where does it reside? It resides in the third quadrant. Because remember, this is quad 1, quad 2, quad 3. And that's why they say it resides in quadrant 3 and in quad 4. Okay. So this is correct. We start here. Okay. So if I rewrite this idea is we begin at the origin. You study the x-coordinate. So either you stay if x is 0, or you move right if x is positive, or you move left if x is negative. Okay. Okay, then you hold your pencil. Don't put a point just yet. Okay. So you have to honor the y coordinate next. Okay. So again, for y, either you're going to stay if it's 0, or you're going to move up if y is positive. Or you're going to move down if y is negative. Okay, but then you would, after that, then you would plot your point. Then you would label your point. Okay, so let's see. So we have some points on the next part. So if you're not done writing, you can pause the video at this point and finish writing that paragraph. Otherwise, if you're caught up with the writing, then you can continue your video. Plot plotting points in a rectangular coordinate system. So I want us to plot these decimals, -4 and 6/10 and -3 and 8/10. Okay, so just as these started off, these are decimals, but this is 6/10. This could have started off as a fraction, -4 and 6/10, because that's 6/10. This could have started off as -3 and 8/10. This is 8/10. Okay, and then these are even. These can be reduced. If I reduce these by 2, this would be -4. 2 goes into 6 3 times, and 2 goes into 10 5 times. So it's -4 and 3/5 when you reduce that. 2 goes into 8 4 times, and 2 goes into 10 5 times. Okay, so they could have started as, the fractions -4 and 3/5 and -3 and 4/5. So if I get my calculator, just check that. Just checking these. If I do 3 divided by 5, that should give me 0.6. So there's a -4. And then here's the fractional part, which is 6/10. This is -3. And if I do 4 divided by 5, that gives me 8/10. Okay, so there's my fractional representation there. So that's just for extra practice there. But when you get ready to plot this point, this -4.6 is telling you you're going to go, you're going to move left. Okay, so you're going to move left. And then you're going to go down. And then you would plot your point. Okay, so if I look at -4.6, -1, -2, -3, -4, and then it's 6/10. Okay, so you're a little bit past -4.5. So you're a little bit past the halfway mark, and then you're going to go down -1, -2, -3. It's -3 and 4/5. So a little bit lower than that. So -3.8. Okay, so you're real close to the -4 here. Okay, so you're at -1, -2, -3, -4.6. So a little bit past 4.5, and then go down -1, -2, -3, -3.8. So you're real close to that -4 there. Okay, and then that's the point. You can call it A, little a, like they're calling it A, or you can call it -4.6, -3.8. Okay, and that point lives in, let's see, your quadrants. This is quad 1, quad 2. This is quad 3, quad 4. So this point lives in quad 3. A lives in quad 3. Quad, short for quadrant. Okay, and then here we have -5/2, 13/3. So these are called improper. So it'd be a good idea to make them into mixed numbers. If you make them into mixed numbers, you do long division. The numerator goes inside the house. So to change improper mix. You want to use long division. Okay, so I do 5 divided by 2. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1 left over. And then it goes clockwise like this. So it's just going to be negative 2 and then 1/2. Okay, negative, which is also the same as negative 2.5. Here, 13 divided by 3, the numerator goes inside the house. Okay. Three goes into 13 about 4 times because 4 times 3 is 12, and then there's 1 left over, and it moves clockwise. So this is equivalent to, and it is a positive 4 and 1 over 3. Okay, so when we get ready to graph that and plot that, you start at the origin at 0, 0, and you're going to move to the left because that's a negative 2.5. Hold your pencil, and then you're going to go up 4 1/3. Okay, so I do that here. So I'm going to go -1, -2.5. Okay, and then go up 1, 2, 3, 4 1/3. Okay, it's a little bit past 4. Okay, so actually here I should have put 4 1/3 here, and then I should have done the decimal up here at the top. So 1/3 is repeating, right? If I do 1 divided by 3, see how that's repeating a bunch of 0.3s. So it just depends, if you round that off to the nearest tenths. There's tenths. If you look at the neighbor, if it's 5 or more, it's not. So this is about 4.3. It's not exactly 4.3, but because it's repeating, right? Wasn't it repeating threes? Remember? 1 divided by 3 is repeating 3. So I think I'll just use a bar on that for that. Okay. So that's represents this fraction here. This is b. Okay, which is the negative 5/2 and the 13/3. Okay. Okay. And that lives in quadrant 2. Okay, then we have the point 30. So 303 says you go to the right 3, and then you actually stay. Okay. So you go to the right 3, but then you stay. Because that you don't go up, you don't go down, you stay. So when I go to my graph paper, I'm at the origin 0, 0, and I go to the right 1, 2, 3, and I don't go up, I don't go down, I just stay. So that's the point 3, 0. 1, 2, 3, and you don't go up, you don't go down, you stay. Okay. And this point lives on the x-axis. 30 lives on the x-axis. It doesn't, you can't say that it lives like in between quadrant 1 and quadrant 4. You wouldn't be allowed to say that. You say that it lives on the x-axis. So this resides, lives on the x-axis. Okay, then we have the point 0, -4. Okay, so here you would stay because of that 0, and then you would go down. Okay, so you stay at the origin 0, 0. Okay, and then you just simply go down 1, 2, 3, 4. Simply go down. That's what they said. So that's the point 0, -4. And that's on the y-axis. 0, -4 is on the y-axis. Okay. Okay, let's see. Excuse me. Okay. Okay, and here they're talking about graphing a linear equation. The completed table is given and the ordered pairs are graphed in the figure. The line through the points is the graph of all solutions to the equation -x plus y equals 2. Okay. So they have these are ordered pairs here. And what they've done is extend this out, did this x, y. So what they've done is they've just, in this table, they have the ordered pairs here. So the completed table is given and the ordered pairs are graphed in the figure. The line through the points is the graph of all solutions to the equation x plus y equals 2. So let's see. Let me see. I'm going to do this. They don't show the algebra. Let me come down here. Um, so I'm going to say that let's randomly choose x coordinates under 10. Okay. So I'm also going to draw this table. Let me get a ruler. So to write the equation right here. Yeah, so I'm gonna just randomly choose x coordinates, and I'm gonna just choose them under 10 as it was. Yeah, it would be the idea. And for example's sake, what they chose, they randomly chose 3, -4, and -1. So I'm going to show you the work how they're getting these y coordinates. So if you let x be 3, okay, we let x be 3. So what we're going to do is we're going to plug in 3 for the x for the x variable. Okay. So in other words, we're going to substitute. And basically what we're going to be doing is solving for y. Okay, so everywhere you have an x, you're going to plug in -3. So here you have negative and then x is 3 plus y equals 2. And then you're going to, so you substitute it. So now we're going to solve for y. We're going to isolate, isolate and solve for y. So we want to move this term over. And the opposite of a -3 is a +3. So what we're using is, your addition subtraction principles. We're using the addition principle here. And what you do to one side of the equation, you do to the other side. And then these will actually fall out. And that gives you 0 because those are called additive inverses. Additive inverses. Number plus its opposite zeros out. So then you have y is equal to, and we don't need any fancy sign rules for this. 2 and 3 is just 5. So y is equal to 5. Okay. So right here, y is 5. And so in your ordered pair, x is 3, y is 5. So when you plot this, you remember you're moving x is 3, so you're moving right, and y5 is positive, you're moving up. So you're going right 3, and then you're going up 5. So I think that's what it should be showing here on this paper. Right 3, so you're here 0, 1, 2, 3, and then you go up 5. 1, 2, 3, 4, way up here 5. So there's your point 3, 5. Okay. Okay, then we're going to go back and randomly choose another coordinate for x, and you can see they randomly chose -4. So you just want to choose something under 10, and then the negatives, the -4 is considered 5. Okay, all right. And so when you let x equal -4, and then you're going to substitute. So right here we have -x. So you have a negative and then a -4. See that? This negative, and then you plug in x, and x happens to also be negative. So we didn't have that happening here when we plug that in, but that's happening here. Negative, negative. And then plus y equals 2. And negative times negative is +4 plus y equals 2. But then when you solve this and you want to solve this for y, you see how you've got to move that over out of the way. So you're going to subtract 4 on both sides. And then these 0 out, fall out. Yeah, y is equal to, and there's always like a little, a little plus sign here, right? It's like imagining a plus sign. You're adding two numbers with different signs. You're adding a 2 plus a -4. You're combining these. So 2 plus negative 4. So your negative is down here, right here. Negative 4. 2 plus negative 4 is equal to negative 2. Okay. And if even if you type 2 minus 2 right here, minus 4, you still get negative 2. Okay. So when you're adding two numbers with different signs, you actually subtract them. 4 minus 2 is 2. And then they're competing, their signs, they're competing. When you're adding two numbers with different signs, they're competing for their sign. So you want the one that's got the bigger distance from 0. So the bigger distance from 0 would be this 4. It's bigger distance from 0 on the number line. Okay? So you're going to go with that number's sign, and that number's sign was negative right here. Okay? All right. So then we have negative 2 here, and this is negative 4, negative 2. Okay, so we got the negative 4 from, I'm demonstrating this up here at the top. They would have randomly have chosen that, and they plugged it in, and they got negative 2. And you see they got a negative 2 also. They just didn't show their work for that. So here you would X, you would move to the left. Okay, then here you would move down, and then you would get ready to plot your point. So negative 4, negative 1, negative 2, negative 3, negative 4. Okay, then you're going to go down to 1, 2. There's your point, negative 4, negative 2. Okay, now we have one last point, which is negative x equals negative 1. I barely have room, so I can squeeze that down here. So x is negative 1. Okay, so we let x equal negative 1. So we have negative and then negative 1 plus y equals 2. Okay? Because you're plugging in, right here, you're plugging in for x. X is a negative 1, so you have double negative. Negative, and then x happens to be negative 1. And so then a negative times a negative is a positive 1 plus y equals 2. And then again, you need to move this over, so you're going to subtract 1 on both sides. Then this is going to fall out. This is going to give you 0. But then over here, you have 2 take away 1. 2 take away 1 is just 1. So then you have y equals 1. So this is a point, negative 1, 1. So you go to the left, negative 1, then you go up. And if you look at your graph, negative 1, 1. There it is right there. There it is, same labeling. Okay. And then the last thing you would do is you would connect your points. We want collinear points. Points that lie for the most part on the same line. So So to form this, we have a slanted line. Okay, this is formed by, slanted line. Yeah, just leave it at that. Oh, I'm gonna say formed by collinear. Collinear points if they lie on the same line. Okay, and then the name of this equation would be this negative x plus y equals 2. That's the name of that equation there. Okay, and so this is a slanted line. And it does have a positive slope. If you think of how are we study graphs from left to right. So how are you approaching your line as you move from right to left? You're going to slowly be moving upwards, upwards, upwards until you can't work with it anymore. So this has a positive slope. Okay, positive slope as you're going upwards as you move, as you study graphs from left to right. Okay. Okay. So those were your pages in your workbook for your COREC. So now you can work on your COREC. Remember your COREC lessons in your COREC folder for Connect Math. Remember that you have a, fo- a folder there that has a Word document that has a list of recommended YouTube videos. So if you ever want to work ahead or you want to supplement the Zoom video or you want to look at those videos that are these YouTube videos that also help you with the COREC lessons then, okay? Okay, so good luck with your homework. Take care.